Example 2. Explain why the function fails to satisfy the conditions of the mean value theorem on the closed interval -1, 1. So what we're going to be doing in these two examples is we're going to be explaining why or if the mean value theorem fails, and if it does, why does it fail. So let's first notice one thing right off the bat, that we do have right here a closed interval. So on the interval of -1 to 1, it is closed. So there are some major things we need for the mean value theorem to work. So for the mean value theorem to work, we need to have some things. One of those is we need to be on a closed interval. The second one is that we're continuous. And third, we are differentiable on the open interval. So we're already on the interval from -1, 1, so that's good. Now we got to look at to see if A is continuous. So let's do a little simplifying. The square root of something squared, we know that like these have to cancel. But we also know that if you square something and take the square root, you're always going to end up with the positive version of it. So I recommend rewriting that like this. A little bit of tricky algebra goes a long way. So just looking at this, I know that this is the absolute value of x plus 1, so it's just this. It's just the absolute value graph shifted up 1, so we know that yes, this is continuous. Now what we need to check to see is if this is differentiable. So to do that, I'm going to graph this on my calculator, and it comes up with something like this. And so I restricted my domain from -1 to 1, so here's -1 to 1, and you'll notice that it's a nice interval here. So everything over here is differentiable. In fact, the derivative here is -1, and the derivative here is 1. But right here at 0, we have a problem. If I were to type in f prime of 0, you're going to see right here is that it's undefined. And it's undefined because if I make the tangent line, you'll see that the tangent line right here is always the same, but as we move this way, it becomes 1. And it's not a gradual, so because it shifts that fast, the derivative from the left is not the same as the derivative from the right. So in our notes, what we're going to write is that f prime, or f, is not differentiable at x equals 0. So because of that, there is no c value. So no c value exists such that the mean value theorem holds. So we cannot find a c value right here such that if I had 2 points like this, it would be the same as the slope of that line. Now let's move on to part B. This is a piecewise function, and piecewise functions seem to get the better of us, so let's see if we can work with this. Step 1, closed interval. We're from -1 to 1. Check. Is it continuous? Okay, we got to check that out. And if it is it differentiable on the interval? Well, first of all, let's see if it's continuous. So let's pull up the graph. So I'm going to get rid of my absolute value graph here. I'm going to pull up the graph. So here's the graph of this function. But we only want it from -1 to 1. So you'll notice that at 1, it's right here. So if I restrict my graph, now I'm going to have something that looks like this. And what I'm going to do is I'm going to go ahead and I'm going to put that in the notes so I can do a little editing with that. So you'll see that right here, the graph is not continuous. And if it's not continuous, then you cannot find a C such that you can find the slope. So this one is no, because the graph is discontinuous at x equals 1. So while you only need to be differentiable on the open interval, which is true for this one, you need to be also continuous on the closed interval.